Every app you open, every game you play, and every video you stream relies on something most people never see: computer architecture. While your computer may look simple on the outside, a screen, a keyboard, maybe a glowing logo inside, it's a world of complexity. Millions, even billions, of tiny electronic decisions happen every second. The way these parts are designed determines everything: speed, power, battery life, gaming performance, and even artificial intelligence. This is the hidden blueprint of modern computing, shaping your digital experience in ways you might never have imagined. Let's take a journey inside the machine to uncover how it all works. Computer architecture is the design of a computer system and how its components work together. Imagine it like a city. The CPU acts as the brain and decision center, memory serves as the temporary workspace, storage is the long-term library, and buses are the highways carrying information. Input devices bring information in, while output devices send results back to you. If these parts communicate efficiently, the computer becomes fast and powerful. If they don't, everything slows down. Understanding this architecture is key to appreciating how your device delivers the performance you expect. Think of your computer as a bustling city. The CPU is the city's brain, making decisions and directing traffic. Memory acts as the busy workspace where tasks are handled quickly. Storage is like a vast library, keeping information safe for the long term. Buses serve as the highways, moving data between different parts of the city. Input devices are the city gates, letting information in, while output devices are the messengers, delivering results back to you. When all these elements work in harmony, the city thrives and your computer runs smoothly. The heart of computer architecture is the CPU, the central processing unit. This is the brain of your computer, responsible for performing calculations and executing instructions. Every time you open an app, type a message, play music, or watch a video, the CPU is hard at work, processing instructions step by step. It's the decision maker, ensuring that every task is handled efficiently and accurately, making your digital experience seamless. CPU operates in a continuous cycle. It fetches an instruction, decodes what needs to be done, and then executes the task. This cycle repeats billions of times every second, allowing your computer to respond instantly to your commands. Whether you're opening an app, typing a message, or playing music, the CPU is constantly fetching, decoding, and executing instructions, keeping everything running smoothly and efficiently. Modern CPUs are more powerful than ever, thanks to multiple cores. A single-core processor can handle only one stream of tasks at a time, but multi-core processors can divide the workload. This means your computer can game, stream, edit, and run background apps all at once without slowing down. That's why modern systems feel smoother and faster, even when you're multitasking. With multi-core CPUs, your computer can handle gaming, streaming, editing, and background apps all at once. Each core takes on a different task, so you can switch between activities without any lag. This is what makes modern computers feel responsive and capable, no matter how many things you're doing at once. RAM, or random access memory, is your computer's short-term memory. It stores data that the CPU needs immediately, making sure everything runs quickly and smoothly. For example, when you're editing a video, the project sits in RAM, allowing for fast access and real-time changes. Without enough RAM, your computer can slow down as it struggles to keep up with your demands. Imagine you're editing a video. The entire project, including all the clips and effects, sits in RAM. This allows the CPU to access everything instantly, making your editing experience smooth and responsive. If your computer runs out of RAM, it has to rely on slower storage, which can cause delays and frustration. The more RAM your computer has, the more tasks it can handle at once. This is especially important for activities like gaming, video editing, or running multiple apps. With enough RAM, your computer can keep everything running smoothly, even when you're pushing it to the limit. Storage is your computer's long-term memory. It's where all your files, photos, videos, and apps are kept, even when the power is off. Think of it as a vast library storing everything you might need in the future. When you open a file or launch an app, the data moves from storage into RAM, ready for the CPU to use. There are different types of storage, like hard drives and solid-state drives. Hard drives use spinning disks to store data, while solid-state drives use flash memory for faster access. The type of storage you have affects how quickly your computer can start up, load files, and run programs. When you save a file, it's written to storage. When you open it, the data is loaded into RAM so the CPU can use it. This process happens seamlessly, allowing you to access your files and apps whenever you need them. The speed of your storage can make a big difference in how fast your computer feels. Buses are the highways of your computer, carrying information between the CPU, memory, storage, and other components. The faster and wider these highways are, the more data can move at once. Efficient buses ensure that your computer's parts can communicate quickly, keeping everything running smoothly. Input devices like keyboards, mice, and cameras are how you interact with your computer. They bring information into the system, allowing you to control apps, enter data, and communicate with others. Without input devices, your computer wouldn't know what you want it to do. Output devices like screens, speakers, and printers send results back to you. They display images, play sounds, and print documents, turning digital information into something you can see, hear, or touch. Output devices complete the loop, making your computer's work visible and useful. For a computer to be fast and powerful, all its parts must communicate efficiently. If the CPU, memory, storage, and buses work together seamlessly, your computer can handle demanding tasks with ease, but if there's a bottleneck, everything slows down and performance suffers. Let's take a closer look at how the CPU works. Every operation starts with the fetch decode execute cycle. First, the CPU fetches an instruction from memory. Next, it decodes what needs to be done. Finally, it executes the instruction. This cycle repeats billions of times per second, powering everything your computer does. The first step in the CPU cycle is fetching an instruction from memory. This is like looking up the next step in a recipe. The CPU needs to know what to do next, so it grabs the next instruction and gets ready to decode it. Once the instruction is fetched, the CPU decodes it. This means figuring out what action is required, whether it's a calculation, moving data, or something else. Decoding is a crucial step, ensuring the CPU understands exactly what to do. Finally, the CPU executes the instruction. This could mean performing a calculation, moving data, or interacting with other components. Execution is where the CPU turns instructions into real actions, making your computer do what you want. This fetch decode execute cycle happens billions of times every second. It's what allows your computer to respond instantly, run complex programs, and handle multiple tasks at once. The speed and efficiency of this cycle are key to your computer's performance. Older computers had single-core processors which could handle only one task stream at a time. Modern CPUs have multiple cores, allowing them to divide workloads and handle many tasks at once. This is why today's computers can run games, stream videos, and edit documents all at the same time. Multi-core CPUs are especially important for gaming and high-performance tasks. Games use multiple cores to handle graphics, physics, and background processes, making gameplay smoother and more immersive. The same goes for video editing and other demanding applications. With multi-core processors, your computer can run background apps without slowing down your main tasks. This means you can listen to music, download files, and chat with friends while working or gaming, all without missing a beat. RAM acts as your computer's workspace, holding data and programs that are currently in use. The more RAM you have, the more space your computer has to work with, making it easier to juggle multiple tasks and large files. When you're editing a video or working with large files, RAM stores all the active data. This allows the CPU to access everything instantly, making your workflow smooth and efficient. Without enough RAM, your computer can slow down, especially with demanding tasks. RAM and storage serve different purposes. RAM is fast and temporary, holding data only while your computer is on. Storage is slower but permanent, keeping your files safe even when the power is off. Both are essential for a smooth computing experience. Hard drives and solid-state drives are the two main types of storage. Hard drives are cheaper and offer more space, but they're slower. Solid-state drives are faster and more reliable, making them ideal for modern computers. Choosing the right storage can make a big difference in performance. Data flows constantly between the CPU, memory, and storage. When you open a file, it moves from storage to RAM, then the CPU processes it. This seamless flow keeps your computer responsive and efficient no matter what you're doing. Buses are essential for moving data quickly between components. The faster the buses, the better your computer performs. Upgrading buses can lead to noticeable improvements in speed and responsiveness, especially for demanding tasks. Every time you type on a keyboard, click a mouse, or use a camera, you're sending information into your computer. Input devices are your bridge to the digital world, allowing you to control and interact with your system in real time. Screens, speakers, and printers turn digital data into something you can see, hear, or touch. Output devices are the final step in the computing process, making your computer's work tangible and useful in your daily life. A well-designed computer balances the power of the CPU, the speed of RAM, the capacity of storage, and the efficiency of buses. If one part is much slower than the others, it can create a bottleneck, limiting overall performance. Balance is key to a smooth and powerful system. A bottleneck happens when one component can't keep up with the rest. For example, if your CPU is fast but your storage is slow, your computer will still feel sluggish. Identifying and fixing bottlenecks can dramatically improve performance. Computer architecture also affects power consumption and efficiency. Well-designed systems use less energy, generate less heat, and extend battery life. This is especially important for laptops and mobile devices where every watt counts. Efficient computer architecture can dramatically improve battery life. By optimizing how components work together, designers can create devices that last longer on a single charge, making them more convenient for everyday use. Gaming pushes computer architecture to its limits. Fast CPUs, plenty of RAM, and powerful graphics are all essential for smooth gameplay. The right balance of components can mean the difference between lag and a flawless experience. Modern computer architecture is also designed to support artificial intelligence. Specialized processors and efficient data flow allow computers to learn, adapt, and perform complex tasks like image recognition and language processing. Computer architecture has evolved rapidly from simple single-core systems to today's multi-core AI-powered devices. Each generation brings new innovations, making computers faster, smarter, and more efficient than ever before. As technology advances, computer architects continue to push the boundaries. They design systems that are not only faster and more powerful but also more energy efficient and adaptable to new challenges like AI and cloud computing. All these architectural choices come together to shape your experience. Whether you're gaming, working, or streaming, the design of your computer's architecture determines how smooth, fast, and enjoyable your digital life is. Understanding computer architecture helps you make better choices when buying or upgrading a device. It explains why some computers are faster, more efficient, or better for gaming and creative work. The hidden blueprint inside the machine truly matters. From the CPU's lightning-fast decisions to the seamless flow of data through memory, storage, and buses, computer architecture is the invisible force behind every digital experience. It's the machine inside the machine, shaping everything you do on your device. As we look to the future, computer architecture will continue to evolve, powering new innovations and experiences. Whether it's smarter AI, longer battery life, or even more immersive games, the blueprint inside your device will keep shaping the world of technology.